Okay, so we've talked about the value of trending with automation systems and portable data loggers, but how do we get there? Well, for larger data logging efforts, we can end up bringing backpacks and boxes of loggers and tools, so we want to be organized about it. We want to understand and document the following key pieces of info: what you want to trend, so what systems or processes are of interest; where you're trending, so physically where the logger goes or where the data comes from; why you're doing the trending. Is it part of some energy conservation measure or perhaps to track down some comfort or O&M problem? When you're trending, so when to start, how long to collect data, and at what sampling interval. And finally, how you're trending, whether to use BAS or loggers, and what BAS points or logger types to use. So there's a document to help us do all this. It's called the Monitoring Plan, and it's an important tool to capture trending needs identified during an initial RCx assessment, to track your progress once you start logging, or to hand off, contract, or QA this type of work. So how to begin? Well, you start with a possible problem or opportunity you may want to look more into. In this case, maybe benchmarking indicated relatively high gas usage, and during your RCX scoping, you noticed this preheat coil enabled despite some mild weather. Since you mapped out your system in this system diagram and using your knowledge of HVAC fundamentals, you recognize that in addition to the extra energy at the preheat coil, this scenario could be resulting in simultaneous heating and cooling at the chill water coil and possibly reheat coil downstream, with additional loads associated with what the plant has to do to provide all this. So one valid question may be, why not dig into the controls and find out what's happening? And as we said during the HVAC fundamental lessons, being able to read logic and understand control systems is a key skill. However, in many cases, a clean view of operation may not be possible. And even where you're able to correctly assess and interpret control logic, there may be other factors at play. For example, in this case, possibly a preheat valve failed or leaking. So once the need for trending has been established, think about what questions you may want to ask the building. Anticipating a calculation of load associated with the preheat coil that is supplied by the plant and possibly being unnecessarily addressed by the cooling coil, you may want to start by focusing on the inputs to these psych equations that you may want to capture. So for instance, the two temperatures representing the delta T across this preheat coil. In some cases, you may determine that front end points are available and acceptable to use. But thinking back to the poor mixed air temperature sensor we saw in the SketchUp air handling unit model, there will be many cases when you may want to supplement with portable data loggers. So this is a key first step, deciding whether you will use BAS versus data loggers to get specific trends and the type and quantity of data loggers you may need. In something like our larger mixed air plenum, you may want a spread of temperature sensor data to better account for things like temperature stratification. This PVC sensor frame is something of an advanced move, but typically there are ways to mount, affix, or otherwise attach sensors or probes where they need to be. This can be a bit of an accessory-driven art form. So now we have some info to start populating our monitoring plan. We have an energy conservation measure, or ECM, which is the preheat coil operating maybe when it shouldn't, a system and location, this AHU's inlet and outlet temps, and a plan of how to arrange our data loggers. The next thing we may want to consider are intervals and lengths we want to collect at. One caution is about aliasing, which is a phenomenon associated with snapshots of data presenting a false impression of actual performance. So for instance, this 5-minute data presumes that 1-minute data would look like this. But in actuality, poorly tuned control loops or some other set of factors may be producing a much more turbulent pattern. On his blog, David Sellers talks about aliasing and other sensor accuracy issues, in addition to highlighting the theory that helps calculate an anti-aliasing sample rate. But David also offers some practical advice on trending intervals. So if you're trying to capture something like these boiler or firing cycles, watch the boiler and do some preliminary timing to see how fine interval you'd need to get to capture that cycle. Or let one logger run at superfine interval for a couple hours, and then based on the results of that, select the longer term interval that you would need to run for your total trend length. Memory can be an issue for lots of fine interval BAS trends communicating on sensitive control network architecture, but it's become less of an issue for portable data loggers. So probably best move is be aggressive and go as fine interval as possible while still getting to your overall trend length desired. You can always resample the data at higher intervals, more on that later. Have a notes column for extra meaningful info. Here we've indicated which ports to use on a 4-channel data logger. And then you're ready to do the trending or to hand off to those who will. These other columns can be used to capture details about launching and reading out the loggers, like the point name or logger ID, launch and download dates, and current status. These things may not be critical for spot checking a specific issue with just a couple loggers, but for a larger effort, this organization is critical. So be aware of templates like this to help keep everything straight. So, recapping the overall process here. We use planning and scoping to help determine what systems we may want to trend. We think about the key metrics for those system operations. Pick the BAS points or loggers needed. Figure out what interval and trend length we want. And then somebody sets up the trends or loggers per the monitoring plan. And this can be done in-house or contracted out using the actual monitoring plan as a scope of work attachment that can be bid against. And after the data is collected, we can go and do the fun work of data analysis and actually see what's going on with these systems. If you're with the RCx Practicum, please follow the link to our SurveyMonkey assessment before moving on to our next section on functional testing. Thanks for watching.